Hello, 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 and good morning, everybody. Happy Monday. Welcome back to Math with Mr. Taco. Today, we are continuing our look at decimal division. Can you think about how far we've come since really in like 1 year, right? A year ago, we were barely getting into division with whole numbers. And here we are in division with decimals. We've divided fractions. We've done a lot this year. It's pretty amazing, and I'm pretty impressed with all of the math learning that has been happening. When people tell you that learning is getting lost, learning can go at any pace, right? And we are pacing it out pretty darn nicely, if I do say so myself. There's what you're going to need. Something to write on, something to write with. There are the I cans down there. I can divide a dividend into equal groups using the standard algorithm. I can express the remainder of a quotient using the tenths place. Now, when we get into, and let me screw this a little bit closer. There we are. Okay, when we get into our division with standard algorithm, remember, divide, subtract, regroup, repeat, right? Those are our steps, right? Divide out the largest place you've got, subtract the amount that you just divided, regroup any remainders to the next place over, and then repeat the process over and over again. Now, up until now, we've been dealing with whole number quotients, whole number dividends, whole number divisors. And on Thursday last week, we ended up with expressing our remainder as some tenths, rather than as a fraction or just saying remainder this many, right? Now, we have this problem here, 352 divided by 4. And we have our standard algorithm format, right? Divide, subtract, regroup, repeat. Let me ask you this. Does this procedure change if I do this? Does our procedure change? I'll even make that decimal point even bigger. Does our procedure change if rather than doing 352 divided by 4, now we're doing 35 and 2/10 divided by 4? The answer in short is no. Our procedure doesn't change. We're still going to divide, subtract, regroup, repeat until we have nothing left to divide out. We're left with 0. Then we're done. We've divvied up all we can. We've dealt all the cards, okay? The fact that there's a decimal point here doesn't change this procedure, okay? Because remember, all this decimal point is showing is where whole numbers end and where parts of a whole number or parts of one begin. But our place 10 concept, base 10 concept still remains in place value. Okay, that was hard to say. Base 10, place value. 10 tenths equal 1. 10 ones equal a 10. 10 tens equal 100, right? That concept of 10 of this thing equals 1 of the next thing, right? And 1 of this thing can be regrouped and decomposed into 10 of this thing over here, okay? That remains no matter how far you go in either direction away from the decimal point. All the decimal point does is that's kind of a marker, right? That's our street sign that tells us we are leaving the city limits of whole numbers and we are entering the city limits of parts of a whole number, right? Same thing when you cross over from Oakland into Berkeley, or from Oakland into San Leandro, or from Oakland into Alameda, right? All it's so it doesn't change the kind of procedure for our division here. It was a long way for me to say that. So we can still divide, subtract, regroup, repeat. So let's do it, okay? So we start with 3 tens. Can we do 3 tens divided by 4? No, not yet, right? If we have 3 tens, I'll draw them out here, right? And we have 4 groups. We don't have enough tens to put in all 4 groups, right? So we can't divide yet. So what we're going to do, above the tens place, we're going to put a 0. Okay? Because 4 times 0 is 0, we haven't put anything into groups yet. We don't have to subtract anything. We're subtracting 0, essentially. Then we're going to regroup our tens with our ones. So now 3 tens become 30 ones. Add that to the 5 ones we have, and now we're doing 35 divided by 4. Okay? So let's use our multiplication chart. How many 4s, how many groups of 4 can we make with 35 without going over? Let's see. Let's take our 4s. How close can we get to 35? Oh, there's 36. That's too many. Let's go back. 32 divided by 4 is something we can do. So what I'm going to do, I'm going to put my 32 below, because that's as close as I can get. I'm going to put a 0 in the 10th place to help me subtract. And then I want to know how many, if I take 32 of my 35.2 and I put them into 4 groups, how many go in each group, right? And that's where our multiplication chart comes back in. 32 divided by 4 is 8. So 8 go in each group. And an 8 goes above the ones place because we were dividing ones, right? So here's where we stand so far. Now, we just divided, let's subtract. We just put 32 into groups, so let's subtract it. Okay, we end up with 3 2/10. Interesting. 3 2/10. That looks a lot like the 32 here, right? So we regroup, and essentially we are dealing with this as 32 tenths. Okay, often this decimal point in the middle will throw people. Okay, but it is still 32. But because we're dealing with tenths, essentially it's 32 tenths, which is equal to 3 2/10, right? If we were to regroup that fraction, okay? So that's 3 2/10, or 32 tenths. So we just knew that 32 divided by 4 is 8, so 32 tenths divided by 4 must be 8 tenths. Zero, zero. And once we have all zeros down here, we are done. So we end up with a quotient of 8 8/10. And we can remove our 0 because we no longer need it. It was just reminding us not to put our first 8 there and end up with 88, which is a much different quotient. Okay? So just like with multiplication of decimals, just like with adding, subtracting of decimals, don't let the decimal point take you off your game. Okay? It's still the same process as adding, subtracting, multiplying, dividing whole numbers. Right? So let's try one more on the digital whiteboard here. Let me move to the digital whiteboard. There it is. So let's try this one. 737 4/10 divided by 6. Okay. Let's go ahead and set that one up for yourself in standard algorithm. And while I check the chat. Got a question in the chat from that last one. Yes. 3 2/10 minus 3 2/10 in that case. Or 32 tenths minus 32 tenths. Is another way to think about it. Okay. So let's go ahead and set this one up here. We're going to put our 6 as the divisor, 737 and 4/10 as the dividend, and then what's going to be our quotient. And if you'd like, you can put the decimal point right up there at the beginning already. Okay, that's perfectly okay. Just to remind yourself that just like with addition and subtraction, right? We want to line up our decimal places and keep all of our places in the same order. So start from your biggest, your largest valued place. In this case, start with the hundreds place. 7 divided by 6. How close can we get without going over, right? We can do 6 divided by 6. And 6 divided by 6 equals 1. 100 in each group. Put the zeros in, take everything down. You know, if you're using the, some mathematicians like to use that kind of arrow method where you're not putting zeros in and you're just bringing the next place down as you go. That's fine too if that works better for you. I prefer this method because it helps me kind of keep all of my remaining dividend in one place. Okay, so now we're going to take our 100, regroup it with our 3 tens. So now we're dealing with 13 divided by 7. 6, excuse me. 13 divided by 6. Okay. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. That's way too many. Okay, so let's go back and let's do 12 divided by 6. We can't do 13 divided by 6 evenly, but we can do 12 divided by 6. And if we do that, we have 2 in each group. And that goes in the tens place because it's 12 tens divided by 6 equals 2 tens. Okay, then subtract it out. We end up with 17 and 4/10 remaining. Okay, regroup our tens with our ones. So now we've got 17 ones divided by 6. And if I remember from the last one, 18 divided by 6 is 3, but that's still too many. So let's use our 12 divided by 6 again. I'm going to scoot this up just a little because I'm running out of space. So we're going to use 12 divided by 6 again because we can't go to 18. We don't have enough. And we're going to put 2 in each one. It's 12 divided by 6 is 2. Put a 0, subtract. And we end up with 5 and 4/10. Now, when we regroup with our tenths, it's important. This is why I'm underlining those 2-digit numbers as we go, because it helps me see what I have to divide. In essence here, I'm going to almost like ignore the decimal point in the middle here. Can you even see this, or am I too far down on the screen? No, you can see it. Okay, good. I'm actually going to ignore the decimal point down here. And I'm really going to think about, okay, that's 54. It's 54/10 because the decimal point's in the middle, but I'm really going to think about 54 divided by 6. Okay? And when I use my multiplication chart and I look down the 6's row, I can see that 54 does divide by 6 evenly. So I'm going to put 54 down here, or 54/10. And I know I'm getting zeros. Okay, now let's look. 54 divided by 6 equals what? 54 divided by 6, it goes up, and 54 divided by 6 equals 9. So we end up with a final quotient of 122 and 9/10, or 122.9 if you want to be all, shorthand about it. Okay, everybody? So with decimals in the dividend, okay, no need to panic. It's the same process as using whole numbers. Okay, in fact, some of you smart cookies may have already noticed that you could move the decimal point until it kind of hides itself, right? By doing 7,374 divided by 6 and then move it back in one place at the end. You could do it that way if that's easier for you. But as long as you're keeping the decimal place lined up, okay, you can really just treat it like any other number because it works the same as any whole number, okay? 10 tenths equals 1, right? 1/10 equals 10 hundredths, okay? Same base 10 system, all right? Thanks, everybody. If you want more questions or you want more questions or you have more questions, please come to office hour. If you want a review of the standard algorithm of division just by itself with no decimals involved, there is a video, I think there's more than one video at this point, on my channel. Go ahead and check that out. Have a wonderful, wonderful day. Good luck, happy math, and I will see you all very soon.